Hello. This is lesson 8.1. We are now starting in our geometry portion of math. This is going to be entitled Similar Shapes and Scale Drawings. So we will be working from pages 237 to 242. So if you need to pause the video to get that, go right ahead and I will see you in a moment. Okay, lesson 8.1, similar shapes and scale drawings. Our standard that we're working from today, now we are in the geometry standards. I can use a scale drawing to find the actual area of an object represented by a scale drawing. So now we just need to do a little understanding of what a scale and a scale drawing is. So a scale is a ratio between two sets of measurements. So in our math examples, it will be a scale number to an actual number. So a scale is often written like this, 1 to 20. It can be written 1 on top, 20 on the bottom just as well. So this means that for every 1 unit on the scale drawing, the actual object will be 20 units. What is a scale drawing? Well, a scale drawing is a two-dimensional drawing of an object that is smaller than the actual object. Scale drawings are used when the actual object is much too big to draw on paper. So blueprints are examples of scale drawings. So now we're going to go under the document camera here, and I will be showing you how to do some problems. Okay, this is example 1 from page 238. On that page, they give you, it says the art class is planning to paint a mural on an outside wall. In your book, the picture is of fish on the mural. This figure is a scale drawing of the wall. What is the area of the actual wall? So let's just draw a little fish on here, because in the book, it's fish, right? There we go. So there's your mural. So now what we want to do, and in the way the book is explaining it is actually a little more confusing. I'm going to show you a better way to do this. And also note that when we did percents, we set up a lot of proportions and a lot of different ratios. So those of you that went ahead and did the percent problems the way I was showing you in class are going to have a way easier time now with this unit because you'll be very familiar with proportions. So let's begin by figuring out how we're going to set this up. Well, we have our scale dimensions. This is not the actual size of the wall. Remember, it's not going to fit on a piece of paper, the actual size. So they drew something that's in miniature, but we want it to be in the same proportions as the actual one. So they gave you the scale ratio of 2 inches is equal to 3 feet. So for every 2 inches on this drawing, that's 3 actual feet on the real mural on the wall. So the best way to set these up is to put the scale ratio like this into a proportion. So always set it up, oh, can't do that. Always set it up like that to start with, just like we did when we did our percents. We set up something over something equals something over something, and there was always one thing missing. Same thing with this. So now they are asking us, what is the area of the actual wall? Well, there's a couple steps we have to take. We have to find, this is our width, and this is our length. So let's start with our width, our 11, right? That's our W, our width. I'll just put width by it in case we forget which one's width. So the scale drawing width is 11. So that's going to go on top because the 2 and the 11 are both in inches. I'll write inches there. And the 3 feet, we don't know what the actual wall is in width. That's what we have to figure out. So we're going to make that be our X. That's our missing piece. And now if you remember how we solved percent problems, we cross-multiplied the 2 we knew, and then we divided by the 1 that was left. So we're going to do that to find the width. So we're going to multiply 3 times 11. Right? What's 3 times 11? 33, and we're going to divide that by 2, correct? What do they want us to find? What is the area? They want us to find the area. So let's figure out what's 33 divided by 2. Well, we can use our calculators, or if you want, sometimes using the calculator is not as fast as doing it by hand, believe it or not. 2 goes into 3 one time. 2 times 1 is 2. 3 from 2 is 1. Bring down the 3. 2 goes into 13. 2 times 6 is 12. Subtract, you get 1. You can make that a half, or you can change it to 16.5. I'm going to use decimals, so I'm going to say 16.5. So the width, the actual width is 16.5. So let's put that up here. The actual width is 16.5, and it's in feet. So we're going to call that feet. I don't know where I can write that, feet. Now we have to figure out the length, the actual length. So we have the scale drawing length. So again, this is our length now. See what I'm going to have to move up. I can keep it all on. No, I'm not going to be able to keep it all on the page. So the length, we have 2 inches is equal to 3 feet, just like before. Nothing's changed there. The only thing changing this time is that we need a different number. So the 2 inches goes to the 28 inches. And we have to figure out how many actual feet that is. So we're going to cross multiply the 2 we know and divide by the 1 that's left. Now you might know where I'm going with this. At some point we're going to have to decide which one's going to be the x, right? So far they're all going to be consistent. So we have 3 times 28. You can calculate that out with your calculator if you need to. Move this up just a tad. That comes to 84. And what am I dividing by? I'm dividing by the number that's left, 2. You can do 84 divided by 2 on your calculator, or you can use long division, or you can just think in your head, well, 2 goes into 8 4 times, and 2 goes into 4 2 times. So 42 feet. So if I go back up here, I will label my length. My actual length is going to be 42 feet. Now we're not quite done yet, because the question asked us, what is the area of the actual mural? Well, that's pretty easy, right? Now we know area is equal to what on a rectangle? Area formula is length times width, right? And we know the actual length and the actual width. So it's going to be 42 times 16.5. And if we do that, what do we get? 693. Now this is where you got to be careful. It's feet squared or square feet. Don't forget, when you're talking about area, you have to put the little 2, because you're talking about how many squares that are 1 foot by 1 foot will fit inside this 2-dimensional shape. So you have to say it's squares. That's a way of saying that. Another way of saying it is just write square feet and not put the little 2. So you got to remember that when you're dealing with area with geometry. Okay, so if you need to pause the video and get this down, go ahead, and then I'll see you in a moment. Okay, this is number 5 on page 239. And the question is saying, find the length and width of an actual room shown in the scale drawing, then find the area of the actual room, round your answer to the nearest tenth. Well, they give us the scale drawing dimensions of 6.5, and I believe that's inches, and this is 5 inches. And they tell us our scale drawing is 3 inches to 8 feet. So the scale ratio is 3 inches to 8 feet. And you really have to kind of look for that scale ratio. It's right below on the bottom of the drawing in your book. It's really small, so you have to just look for it. So I'm going to use the method that works really well for this. So let's see if we can remember what we have to do. We have 3 inches is equal to 8 feet. Okay, there's our proportion that we've set up. They want us to find the actual length and the actual width of, what was it, just of this rectangle, I guess. So we know the length and the width. So let's start with the width. I'll try to do this all on one line this time. And then the length is going to go over here, like that. And both times we're going to use 3/8, right? For both the length and the width. And now what we're going to do is we're going to say, well, what do we know for the width? We know the scale size, that's 5. Always be careful that your scale goes with your scale inches on the top. We got to keep them together. And what are we trying to find? The actual, right? So this is the scale side, or the scale row, and this is the actual row, if that helps. So now we cross multiply and divide by the number that's left. Okay, maybe I should put a little division sign there. Okay, so we do 8 times 5 equals, right, 40, divided by, exactly, 3. So that's not going to come out exactly even. You do that on your calculator, you get 13.3 feet. Don't forget, the bottom is in feet. The actual size is a lot bigger than the scale size. So that's our width. Now we do the same with the length. What's our top number? Exactly, 6.5. Put inches so we know we're dealing with inches to inches. On the bottom, we have to go feet to feet. We need to find the actual feet. We don't know what that is. So that's our actual. That's what we're trying to find. Remember, there's always going to be one thing missing in a proportion. So we're going to cross multiply what we know. And we're going to divide by the number that's left. So cross multiply 8 times 6.5. That gives you 52. And then you're going to divide by 3. Divide by 3. It's going to not come out exactly even. It's going to come out as 17.3 feet. About. Okay, we're not quite done because the problem asked us find the area of the actual room. Well, now we've got the actual dimensions. So we know that area of a rectangle is equal to length times width. We know our width, 13.3. We know our length, 17.3, and we times them together. And we want to round it to the nearest tenth, so we're going to end up with 230.09 something, ... on our calculator, which rounded up to the nearest tenth. Here's your tenth spot, T-E-N-T-H, tenth spot. You got to look at the guy next door, piece 5 or more, you're going to round up 1 on the 10th spot. So it's going to become 230.1 feet squared. Don't forget the little square. Now we're talking about area. So that is the answer to number 5 on page 239. If you need to pause, go right ahead, and then we'll see you for the next problem in a moment. Okay, this is Explore activity number 2 on page 239. I just want to show you a couple of examples of what happens here when you change the scale. So this is a scale that says on the page it represents 1 centimeter to 3 meters. So we're assuming that each one of these squares is 1 centimeter. So the scale then is, scale is 1 centimeter is the same as 3, was it 3 meters? 3 meters to the actual size of the object, whatever that object is, whether it's a garden or a wall or whatever. So what the question is asking us on this, suppose you redraw the rectangle on centimeter grid, which we have it there, using a scale of 1 centimeter equals 6 meters. In the new scale, so let's just do that first to see what's happening here. So we want to change it to a new scale of 1 centimeter is equal to 6 meters. Now don't get confused by this. It's a little different than our proportional setup. So what we need to do is we have to say, well, the scale went from 3 to 6. Oops, I can't see that. The scale went from 3 to 6, which if we reduced 3/6, that's the same as what? Exactly, 1/2. You can leave it 3/6. You can reduce it if you want to work with smaller numbers. It reduces down to 1/2. And then we have to times that by the number of units or number of squares, whatever you want to say, number of units of the scale drawing. So we got to go back up here and find the number of units on the scale drawing, depending on whether we're talking about length or width. So we'll do width first. So let's go up to the top here. Here's our width, right? W. I'll put it in blue. W is our width, and this is our length. This is of our scale drawing. We're not trying to find the actual area right at the moment. We're just trying to change the size of our scale drawing. So we're going to count our width squares. 1, 2, 3, 4, 5, 6. We have 6 currently. How many do we have length? 1, 2, 3, 4, 5, 6, 7, 8. Equal to 8. Okay? So now we want to change our scale. So we're going to take our 1/2. This is for our width now. Our width is going to equal 1/2 times the current number of scale units, 6. And we're going to put that over 1 because we're not doing missing an X now. We're not doing that. We're just trying to reduce or increase the size of our representation of centimeters to meters. So now we can cross off what we know. So the 2 will go into the 6 3 times, and that'll become 1. So that width would turn into 1 times 3 on the top and 1 times 1 on the bottom, or 3 units. So our new scale will be a width of 3 units. So let's go ahead and draw that. 1, 2, 3. Our new width is going to be 3 units. So the new width is 3 units with our new scale. Now we have to figure out the length. So length is equal to 1/2 times, what's the current number of length units? 8. So we're going to multiply by 8 over 1. So it's really taking half of 8, basically. So 2 will go into 4 and cancel out. 2 goes into 8 4 times. Oops, gave you the answer. 2 goes into itself once. And now I end up with 1 times 4 on top, 1 times 1 on the bottom. And if I multiply that out, I end up with 4 units. So let's draw that. Let's go back up to our length here of our new scale. Our new scale, we have 4 units. So 1, 2, 3, 4. We have to go just to there. Now I can draw my rectangle here. Okay, this is a new scale of 1 centimeter equals 6 meters. Notice the size change in the scales. So the question in the book is saying, suppose you redraw the rectangle, which we just did. In the new scale, 1 centimeter represents blank, more or less than 1 centimeter in the old scale. Well, that's easy. 1 centimeter in the old scale represented 3 meters. Now it represents 6, so the answer is more than. It represents more. And then it says the measurement of each side of the new drawing, from the old blue one to the new pink one, will be either twice or half as long as the measurement of the old drawing. Well, we already figured out that it's going to be half the size, right? And if you think about it, this was 6, half of 6 is 3. This was 8, half of 8 is 4. So it will be half the size. Our new drawing has shrunk down, right? Not the actual size of the object. That's still the same size. It's just the scale we're using has shrunk down. Okay, now we are on to the guided practice, page 240, which you do have to turn in as homework. So if you need to pause the video and get that paper out, go ahead so that you can fill this in as we go. So number 1 says the scale of a room in a blueprint is 3 inches to 5 feet. A scale in the same blueprint is 18 inches. Complete the table. Okay, so how long is the actual wall is A, and B is a window in the room has an actual width of 2.5 feet. Find the width of the window in the blueprint. So let's begin filling in this table first of all. So the easiest way is we know that the scale, I'm going to write that in blue, all these choices of colors here. So the scale, the book told us, was 3 inches to 5 feet. And that's given in the book. And then they also told us that the wall is 18 inches. We'll get to that in a minute. So first we got to fill in this table. Well, we know the actual length when it's 3 inches on the scale is what? Exactly, 5 feet, right? Told it to us. So now we have to figure out these other numbers. So how do we figure that out? Well, we have 3 inches to 5 feet is equal to, and I don't know if they put in those other numbers for you, but we're going to go up by 3s, okay? So we're going to go up to 6 next, and then we're going to go to 9, 12, 15, and 18. Why did I go up to 18? Because, well, that's where our table ends in our book, but also because the question is asking us a wall in the same blueprint is 18 inches. So we're going to complete the table, so we have to go up to 18. So we use our proportion method. We know that 6 inches goes here. The actual feet is our x. Okay, then we're going to cross multiply and divide. 5 times 6, these two, is 30, divided by 3, exactly 10. So that number goes here. So if the blueprint is 6 inches, the actual length of the wall or whatever it is 10 feet. So you can see where I'm going from here. Now we have 9. So we have 3 inches to 5 feet is equal to 9 inches to x feet. Cross multiply what we know. 5 times 9 is 45. Divide by the 3. 45 divided by 3 is 15. So that's the number that goes up here. Then we do it again for the 12. 3 inches to 5 feet. Always start with your ratio, your scale, right? Now we have 12 inches. We don't know how many feet. That's what we're trying to find. A lot of you can probably do this in your head. 5 times 12, Right, that's 60 divided by 3. So 5 times 12 equals 60 divided by 3 equals, you got it, 20 feet. So 20 goes here. You'll notice that the amount that it goes up is going to be constant. If this is constant, it needs to stay constant. It's going to go up constantly, going up by 5. So we could keep working on that, or we could realize there's a pattern there. But we're going to just go ahead and finish this off. 3 feet, or 3 inches to 5 feet is equal to 15 inches to x feet. 5 times 15, 75, divided by 3. 75 divided by 3 is 25 feet, which goes up by 5 like we knew it would. And then the last one is 3 to 5 is equal to 18 to blank. So 5 times 18 equals 90, divided by 3 equals 30 feet. So 30 goes here. We got our table filled in. Now the question is asking us number A, or letter A, how long is the actual wall? So A, and how do we know? Because it's asking us for a wall is the same blueprint as 18 inches. So we know that the wall, find the 18, the wall is, what goes with the 18? What's its partner? Yep, 30 feet, right? B says a window in the room has an actual width of 2.5 feet. Find the width of the window in the blueprint. The blueprint meaning the scale, right? So we know that it is 2.5 feet. This is a good one to do because watch what's happening on this one. We already are given, so we're going to set it up as a proportion. We still have our, oops, can't see that. We still have our 3 inches to 5 feet, 3 inches to 5 feet scale. But now they're telling us the actual size of the room, right? Is it a room? No, a window. Actual size of the window is 2.5 feet. Be careful, because this is the actual size. The actual sizes go together. This time they want us to find the scale size. So now we have to put the x there. We still solve it the same. We cross multiply the two diagonals that we know, and then we divide by the remaining number, just in a different spot. So we have 3 times 2.5, that's 7.5, and we're going to divide that by 5. 7.5 divided by 5 is going to give you 1.5 inches. Why did I say inches? Inches goes with inches. We're trying to figure out the scale size. So that's the answer to number B, 1B. Pause it if you need to. We'll be right back on number 2. All right, this is problem number 2 on page 240, the guided practice. And I drew the rectangle. The question is asking us, the scale in the drawing is 2 inches to 4 feet. Okay, let's write that scale here. 2 inches to 4 feet. There we go. Then it says, what are the length and width of the actual room? And then find the area of the actual room. So we're going to do what we've been doing. So we're going to do our 2 inches to 4 feet is equal to, and now we're going to do the width first. So our width is 7, right? 7. So 7 inches is equal to the actual. We don't know. That's what we have to find out, the actual. Cross multiply what we know diagonally. Divide by the number that's left. 4 times 7. Yep, 28 divided by 2. 14 feet is the actual width. Now the actual length, same thing. 2 inches to 4 feet. 2 inches to 4 feet is equal to, well, we know 14 is our length in inches with the scale drawing. We are looking for the actual length. Cross multiply what we do know and divide by the number that's left. So we do 4 times 14, 56, and we divide by the 2. 56 divided by 2, all you math people out there, yep, 28. 28 feet. Okay, now we have the length and the width. Then we need to do the area. So this is the first part of the question. We found the width, we found the length, and now area, the last part of our question. Area equals length times width. Width is 14, length is 28. 28 times 14 gives us 392 square feet. Or you could say 392 feet with a little 2. Either one of those is the right way to write this. So that's the answer to number 2. Okay, same one for number 3. It says, the scale of the drawing is 2 centimeters to 5 meters. What are the length and width of the actual room? Find the area of the actual room. So our scale is 2 centimeters to 5 meters. 2 centimeters to 5 meters. Our scale, meaning that for every 2 centimeters on our scale, our actual room size is 5 meters. So we are going to reset that up. Same as the last problem. So we're going to set up 2 on top, 5 on the bottom. And then what are we going to do? Well, we're going to take our width of 6 centimeters and put it on the top. And we're going to figure out the actual size in meters. That's for our width. And our length, again, we're going to do the scale of 2 to 5, 10 on top, finding the actual length. And then it asks us to find the area of the room. So then the area will be length times width. I'm not going to do that problem with you because I want you to do that one and give that one a try. So we're going to go on to number 4. This is guided practice, page 240, number 4. A scale drawing of a cafeteria is drawn on centimeter grid paper as shown. So we're assuming that each one of these squares is 1 centimeter in length. In fact, let's see if it really is. It might be. It is. This is exactly centimeter paper. So it is 1 centimeter. The scale is 1 centimeter to 4 meters. Scale 1 centimeter is the same as 4 meters of the actual size. Oops, not equals. Little colon there. And then it says, what are the length and width of the actual room? Oh, I'm on the wrong one, sorry. Then it says, A, redraw the rectangle on centimeter grid paper using a scale of 1 to 6. A little different kind of problem, remember? And then B is, what is the actual length and width of the cafeteria using the original scale? So we'll come back to that in a minute. And what are the actual dimensions of the cafeteria using the new scale? Okay, so A, this is going to be a little different. We are changing from a scale of 1 centimeter to 4 meters to a scale of, and the new scale, I'm going to do that in pink here. Our new scale has to become, the book tells us, what? 1 centimeter to 6 meters. Okay, so we have to figure out our new size. Well, let's count what we have for our original size. 1, 2, 3, 4, 5, 6, 7, 8, 9 centimeters, right? Or 9 units. How many going down? 1, 2, 3, 4, 5, 6 units here. Now we have to shrink it down to 6 per centimeter, right? So our steps are 4 is what it was. Now it is 6, right? Times the number of original units. Number of original units, right? So if I want to use smaller numbers, I can reduce that, and I'm going to. So if I divide by 2, I get 2 on top. And if I divide the bottom by 2, I get 3 on the bottom, right? Okay, so we're going to use 2/3. That's the same as 4/6. It's just a reduced fraction times the number of original units. So we have to do length and width. Here's our width. So the number of original units was 6, or 6/1. And then we can cancel some things out here. So the 3 will go into 6 2 times. The 3 will go into itself once. So now I'm left with, on the top, 2 times 2, and on the bottom 1 times 1, which is the same as, yes, 4 units. So 4 units. That's my width. I'll put a W by that, so remember. So we can go ahead and draw that 4 units width for our new drawing. So we need to start there. 1, 2, 3, 4. So my new width is going to be 4 units, like that. And remember, it's going to be 2/3 the amount. And then our length is the next one. So we're going to move down a little bit here. Again, we have a ratio of 2/3 times the number of original units. Original units for length was 9 times 9. We're going to put 9 over 1. We're going to cancel what we can. 3 will go into 9 3 times. 3 will go into itself 1 time. I'm left with 2 times 3 on the top, 1 times 1 on the bottom, or 6 units. And that is my length, is 6 units. So we can go ahead and draw that in. So 1, 2, 3, 4, 5, 6 should be 2/3 the size, right? Because that was our ratio change. 1, 2, 3, 4, 5, 6. Yep. So that will be 6. So it should shrink because we're using 1 centimeter equaling more meters, not less. So that is A. We drew the picture. Now B is, what is the actual length and width of the cafeteria using the original scale? So the original scale was 1 centimeter to 4. So let's put that in over here. 1 centimeter to 4. This is the original. It was 1 centimeter to 4. And then we have to set that equal to, we need the width and the length. So the original width was 6. And the original length was 9. So original length was 6 units to, we don't know what we were trying to find the actual. And the other one is 1/4. This is for width. And this will be for length. 1/4 is equal to 9. We don't know, right? And then we cross multiply and divide. This will be an easy cross multiplying and dividing. So let's see, this will come out to 4 times 6, 24, divided by 1, which is super easy, just 24. That's our width. Our length is 4 times 9, 36, divided by 1, which is super easy, 36. That's our length. So what did the question ask us? What is the length and width? Okay, now let's see what is it with the new scale. So now we're going to do with the pink scale and see what we come up with. So now using the new scale, our new scale is 1 centimeter to 6 meters. So that's going to be 1 centimeter to 6 meters. And then we have our numbers. Our width is 4 now. 4 to x. That's going to be our width. Our length is going to be 6. So our new scale is 1 to 6 is equal to 6 over x. And we solve that, and we should get a little bit of room at the bottom. 4 times 6 is 24, divided by 1 is 24. The second one is 6 times 6 is 36, divided by 1 is 36. Did you notice anything? We changed the scale from the original to the new, but what happened to the actual size of the object? It stayed the same, didn't it? So the scale is the only thing that changed. The actual size of the object did not. So number 5, I'm not going to do. I'm just going to tell you the answer. If you have an accurate, complete scale drawing and the scale, which measurements of the object of the drawing can you find? Well, you can find any length or any width with a scale drawing, right? You've got the ratio. You can just find any one. So now I'm going to go on to, we have some homework. I'm actually going to do number 11 with you. That's on page 242. So if you want to pull that out, that's one of your homework pages. So we'll do that together. Okay, this is page 242, number 11, one of your homework problems, the only one on that page that you have to do. You have been asked to build a scale model of your school out of toothpicks. Imagine your school is 30 feet tall. So the school is 30 feet tall. That is the actual, right? So we keep that in mind. Your scale is 1 foot to 1.26 centimeters. So 1 foot of the school building, the actual, is represented as 1.26 centimeters of the scale. So in our case now we have the actual to the scale. It's just stated a little differently this time. So A says, if a toothpick is 6.3 centimeters tall, so the toothpick, we'll put that here, toothpick equals 6.3 centimeters tall. That's the actual size of the toothpick, right? How many toothpicks tall will your model be? So how do we set this up? Well, we're going to start by putting our scale up here. And I'm going to keep it in this format because that's what we've been used to. As long as I keep centimeters with centimeters and feet with feet, I'll be okay. So now we know the actual feet of our school is 30. So keep the feet with the feet, keep the centimeters with the centimeters. So we don't know what our scale has to be in centimeter height. So now we solve it. Cross multiply what we know diagonally and divide by the number that's left. So we know 1.26 times 30 equals 37.8 divided by 1 remains 37.8. And what is our measurement number? What unit are we going to be using? Centimeters, correct. Why centimeters? Because centimeters has to go with centimeters. We're trying to find the drawing. But that's not what question A is asking us. Question A is asking us, how many toothpicks do we need? So we have one more step. So the last step to get the answer is, let's move this up a little bit. We know a toothpick is 6.3 centimeters high. So we know we need to go all the way up to 37.8, right? And we know that one toothpick is going to be 6.3. Here's our toothpick. How many toothpicks more do we need to get to that top? Well, we can divide, right? How many 6.3s go into 37.8? 37.8 divided by 6.3. We use our handy dandy calculator. Comes to 4.97. So approximately 5 toothpicks. That's the answer to A. Approximately 5 toothpicks are needed. Letter B, now they're changing from toothpicks. Your mother is out of toothpicks and suggests you use cotton swabs instead. You measure them and they are 7.6 centimeters tall. How many cotton swabs will you need? Actually, did I do something wrong on there? Oops, yeah, you know what? I calculated this wrong. This is approximately 6. Approximately 6. I was looking at the next problem. So when I divide, and I'm going to take my calculator for a minute just to see what I get. 37.8 divided by 6.3 is exactly 6. Okay. It's not approximately. It's exactly 6. I was looking at the letter B. Okay, now letter B. I didn't mess anybody up on that one. You'll be like, I gotta erase it now. Okay, letter B. It's the same thing, except now we have cotton swabs, and the cotton swabs are a little bit taller, 7.6. So do you think you're going to need more or less cotton swabs if they're taller than the toothpicks? Right, you should use a little less, and I've already given you the answer because I gave you the answer to B instead. So divide by 7.6, and you should get, that's where we get the 4.97. So that's approximately, that means approximately, by the way, in math, approximately 5 toothpicks. So it should be a little less than, I mean, not toothpicks, swabs. So you should have a little bit less swabs than toothpicks. Messy. Get rid of this. Okay, so that one I did for you. And we'll talk about your homework. Okay, back to the screen. Our homework is to do page 240 guided practice, and I pretty much did that all with you, except for that one problem. We just didn't do the calculations. And then page 241, I want you to do number 6, 7, 8, 9, and 10. And then page 242, number 11, A and B, the one we just did at the end of this video. So you're always welcome to do the hot problems. Those are the higher order thinking problems, and they will be 2 extra credit points, but they're optional. You do not have to do them. You don't have to get them correct, but you have to show that you tried them. So I hope you have a good day, and we'll see you next time. Goodbye.